The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so after determinants, now I can tell you about cross-product. And cross-product is going to be the answer to your question about area. Okay, so let me move on to cross-product. So cross-product is something that you can apply to two vectors in space. And by that I mean really in three-dimensional space, okay? This is something that's specific to three dimensions. So the definition, A cross B, so it's important to really do your multiplication symbol well so that you don't mistake it with a dot product. Well, that's going to be a vector okay, so that's another reason not to confuse it with dot product. Dot product gives you a number, cross product gives you a vector. So they're really completely different operations. They're both called product because, well, somehow one couldn't come up with a better name, but they're completely different operations. Okay, so what do we do to do the cross product of A and B? Well, we do something very strange. Just after I've told you that a determinant is something where we put numbers and we get a number, I'm going to violate my own rule. I'm going to put together a determinant in which, well, the last two rows are the components of the vectors A and B, but the first row, strangely, consists of the unit vectors I, j, k. What does that mean? Well, that certainly is not a determinant in the usual sense. You cannot, if you try to put that into your calculator, it will tell you there's an error. I don't know how to put vectors in there. I want numbers. What it means is it's a symbolic notation that helps you remember what the formula is. So the actual formula is, well, you use this definition, and if you use this definition, you see that it's I hat times some number. Okay, so let me write it as determinant of A2, A3, B2, B3 times I hat minus determinant A1, A3, B1, B3, J hat plus A1, A2, B1, B2, K hat. Okay? And so that's the actual definition in a way that makes complete sense. But to remember this formula without too much trouble, it's much easier to think about it in these terms here. Okay, so that's a definition. And it gives you a vector. Now, as usual with definitions, the question is, what is it good for? What is the geometric meaning of this very strange operation? Why do we bother to do that? So here's what it does geometrically. So remember, a vector has two different things. It has a length and it has a direction. Okay, let's start with the length. The length of a cross product is the area of the parallelogram in space formed by the vectors A and B. So now if you have a parallelogram in space, you can find its area just by doing this calculation when you know the coordinates of the points. You do this calculation, and then you take the length. So the length, you take this squared plus that squared, square root. It looks like a very complicated formula, but it works, and actually it's the simplest way to do it. Okay. This time we don't actually need to put plus or minus because the length of a vector is always positive. We don't have to worry about that. And what's even more magical is that not only is the length remarkable, but the direction is also remarkable. So the direction of A cross B is perpendicular to the plane of a parallelogram. So, our two vectors A and B together they determine a plane. And what I'm telling you is that the vector A cross B will stick straight out of that plane, perpendicularly to it. Okay. So in fact, I have to be more precise. There's two ways that you can be perpendicular to this plane. Right? You can be perpendicular pointing up or pointing down. How do I decide which? Well, there's something called the right-hand rule. Okay, so what does the right-hand rule say? Well, there's various versions of the right-hand rule depending on in which country you learn about it. In France, given the culture, you even learn about it in terms of a corkscrew and a wine bottle. But I think I'll just use the usual version here. So you take your right hand. If you're left-handed, remember to take your right hand, not the left one, the other right. Okay. And then place your hand to point in the direction of A. So let's say my right hand is going in that direction. Now, curl your fingers so that they point towards B. So here that would be kind of into the blackboard. Okay? Don't snap any bones. If it doesn't quite work, then rotate your arm so that you can actually physically do it. Then get your thumb to stick straight out. Well, here my thumb is going to go up, and that tells me that A cross B will go up. Okay? So let me write that down while you experiment with it. Again, try not to injure yourselves. So first, your right hand points parallel to vector A. Then fingers point in the direction of B. Then your thumb, when you stick it out, is going to point in the direction of A cross B. Okay? Let's do a quick example. Where's my quick example? Here. Let's take I cross J. So I see some of you, well, most of you have it going in the right direction. If you have it pointing in the wrong direction, it might mean that you're using your left hand, for example. Okay. So, example, I claim that I cross J equals K. Okay. Let's see. I points towards us. J points to our right. So I guess this is your right? I think. It's kind of hard to. And then your thumb is going to point up. Okay. So that tells us it's roughly pointing up. And of course, the length should be 1, because if you take the unit square in the xy plane, its area is 1. And the direction should indeed be vertical, because it should be perpendicular to the xy plane. So it looks like I cross j will be k. Well, let's check with the definition. ijk, what is I? I is 1, 0, 0. J is 0, 1, 0. Well, so the coefficient of I will be 0 times 0 minus 0 times 1, that's 0. Coefficient of j will be 1 times 0 minus 0 times 0, that's 0, minus 0j, doesn't matter, but. And the coefficient of k will be 1 times 1, that's 1, minus 0 times 0, so 1k. Okay? So we do get I cross j equals k both ways. In this case, it's easier to do geometrically. If I give you more complicated vectors, probably you will actually want to do the calculation. Okay, any questions? Yes?
Real quick, how did you figure out the 1 times 1 in the last?
So the coefficient of k, remember I delete the first row and the last column. So I get this 2 by 2 determinant. Okay, that 2 by 2 determinant is 1 times 1 minus 0 times 0. So that gives me 1. Okay? That's what you do with 2 by 2 determinants. Similarly for the others, but the others turn out to be 0. More questions? Yes, let me repeat how I got the 1 in front of k. So remember the definition of a determinant, I expand according to the entries in the first row. When I get to k, what I do is I delete the first row and I delete the last column, the column that contains k. Okay? So I delete these guys and these guys. I'm left with this 2 by 2 determinant. Now, a 2 by 2 determinant, you multiply according to this downward diagonal, and then minus this times that. Okay, so 1 times 1. Let me say here, I got 1k because that's 1 times 1 minus 0 times 0 equals 1. Sorry, and that's really hard to read. Maybe it will be easier that way. Okay. Yes?
So for I and j, do the same, because it seems that if you do the same with I, you will get -1.
Okay, so let's try. If I do the same for I think I will also get 0. Okay, so let's do the same for I. So I take I delete the first row, I delete the first column, I get this 2 by 2 determinant here, and I get 0 times 0, that's 0, minus 0 times 1, that's here the trick question. 0 times 1 is 0 as well. So that's 0 minus 0 is 0. Okay? So I hope in Monday you should get more practice in recitation about how to compute determinants. So hopefully it will become very easy for you all to compute these things. I know the first time it's kind of a shock because there's a lot of numbers and a lot of things to do.